So yesterday we have learned, sorry. Okay, yesterday we have learned redox reaction. So in terms of electron transfer, can you say what is oxidation? What is reduction in terms of electron transfer?
Miss, oxidation is the loss of electrons.
Yes, so we can say that oxidation means loss of electron. So reduction will be the opposite. Reduction just will be the opposite, gain of electron. So our today's topic is oxidation number. Our today's topic is oxidation number. Okay, let's see what is oxidation number. See, what is oxidation number? It is the oxidation state of an element in a compound, which is the charge assigned to an atom of a compound is equal to the number of electrons in the valence shell of that atom that are gained or lost completely to a large extent by the atom while performing in a bond, while forming a bond in a compound. So actually, we can say that it is the charge, okay, which an atom of the element has in its ion or appears to have when present in the combined state with other atoms. Like if we say HCl, if we consider suppose HCl, okay, so HCl is present over here, what? H plus and Cl minus. HCl is present in HCl compound in H plus and Cl minus. Yes, Atanu, just mute yourself. Okay, so H plus and Cl minus. Say this H plus, that means the oxidation of hydrogen will be +1 and the oxidation number of chlorine will be -1. So it is the charge actually. When the element are forming compound, okay, when the number of electrons from the valence shell should be gained or lose, that is actually the charge. That is actually the charge assigned in an atom. Clear? Actually, it is actually an imaginary number. Okay, it is it is totally imaginary. Clear? Suppose if I consider one more example, like if we consider one more example like NaCl. So Na is present over what? Na plus Cl minus, sorry, Na plus and Cl minus. So its oxidation number will be +1, it will be -1, like this. If I consider water, see, so we know that water is more electronegative than hydrogen. Water is more electronegative than hydrogen. So what water will do? Water will absorb the electron towards the oxygen. Okay, so what oxygen will do? Sorry, what oxygen will do? Oxygen will pull this bonding electron towards itself because it is more electronegative. So it pull its bond from both the sides, from this bond, from this bond. So its charge will be -2, and hydrogen will have charge +1. Clear? If we consider carbon dioxide, see, this is the structure of carbon dioxide. So obviously, electronegativity of oxygen is more than that of carbon. So this oxygen will pull this bonding electron towards itself. This oxygen will pull these two bonding electron towards itself. So their oxidation number will be -2, -2. And obviously the oxidation number will be Carbon will be +4 because it's give its electron towards the 4 bonds. This 1, 2, 3, 4. That's why its oxidation number will be 4. If we consider ammonia C, this is the structure of ammonia. Ammonia is more electronegative than hydrogen. So ammonia will pull its electron. No, sorry, not ammonia actually. This ammonia, in ammonia, nitrogen is more electronegative than hydrogen. Then what? Nitrogen will pull the electron towards itself through this bond, this bond. So it will have a negative charge. So 3 negative charge. So the oxidation number will be -3. And obviously hydrogen will have +1 because they are giving their electron towards nitrogen, because nitrogen is more electronegative. It pulls the electron towards itself. Clear?
Yes, ma'am.
Okay. Now next, very important, that is rules for calculating oxidation number, ON. Okay, I'm writing in small oxidation number. So first one is for element in free state, for element in free state, oxidation number will be 0. When the elements that remain in free state, their oxidation number will be 0. Like fluorine, nitrogen gas, oxygen gas, okay? Then fluorine, then see hydrogen, iron, we can say rubidium. That means when the elements are remain in free state, when the elements are remaining in free state, their oxidation number always will be 0. So this rule is clear.
Yes, miss.
Okay. Now next is for single atom ions. For single atom ions, okay, oxidation number is equals to charge on ions. Okay, for single atom ions, oxidation number is equal to charge on ions. Like
मम्मी को मदद करना चलाए दे आवारा कहीं जाए आवारा
okay, sorry. So for single atom ions, oxidation number is equals to charge on ions. Okay, so like Cl minus, so its oxidation number will be -1. For suppose magnesium 2 plus, so its oxidation number will be +2. Okay, for suppose aluminum 3 plus, okay, aluminum always present in 3 plus, so its oxidation number will be 3 plus when they are present in a single atom ion. Just like sodium plus, that means its oxidation number will be +1. Okay, just like if we consider oxygen 2 minus, that means its oxidation number will be -2, like this. 3, rule 3. Just like oxidation number of fluorine, these are the things you have to remember, otherwise you cannot calculate the oxidation number. And if you don't know how to calculate the oxidation number, you cannot do the balancing. Okay, redox reaction you cannot balance. So oxidation number is very important for that. See, for oxidation number of fluorine will be always -1. Always. Sorry. Always it will be -1. It will be always -1 because fluorine is the most electronegative element. So fluorine will have always its oxidation number that is -1. Okay, if I consider suppose oxygen contain various oxidation number, various. Okay, when the oxidation number of oxygen is -2. Okay, when the oxidation number of oxygen is -2, they known as oxide. Okay, and its formula will be like this: O2 minus. Okay, when the oxidation number -1, when oxidation number -1, it's known as peroxide. Peroxide. So O2 2 minus that. Okay, that means 2 minus ion will be shared by 2 oxygen atom. When oxidation number is -half, that is superoxide. That is in case of superoxide, O2 minus 1. That means 1 negative charge will be shared by 2 oxygen atom. Now, can you tell me? Oxygen, we know that is the electronegative element. So can the oxidation number of oxygen be positive? What do you think? What do you think? Oxidation number be positive for an oxygen atom, which is a electronegative ion. Obhinav, any idea? Odityo? Oxidation number may be positive for oxygen. What do you think? Devanna, Shoumarjo, any idea? How do I understand? See, oxidation number of oxygen should be positive also. So Obhinava, why are you having problem? Just tell me.
In that only, that why it will be positive.
Why will be positive? That I will show you. See, in OF2, see, if I draw the diagram for OF2, this is for OF2. Which one is more electronegative, fluorine or oxygen? Who is
Fluorine.
Fluorine. So obviously, fluorine, you know, what will say to oxygen? That give me your bonding electron, because I am more electronegative, I need the electron. So fluorine will take the electron from oxygen. Okay, so obviously, obviously a negative charge will develop in fluorine. So fluorine will have -1 because fluorine is most electronegative. Its oxidation state always will be -1. So what will be its charge? What will be its oxidation number? Positive? Yes or no? Understood?
Yes, ma'am. Yes, ma'am.
Okay. Now it can also be +1, because suppose if O2F2 like compound form, if O2F2 like compound form, then in oxidation will always be its oxidation will be +1. Clear? Because fluorine is more electronegative, it will take the electron, bonding electron pair towards itself. So these are the oxidation number of oxygen. You have to remember, very important. Clear? Should I move to the next rule?
Yes, ma'am.
Yes, miss.
Now, next, alkali metal. Alkali metals always have +1. Always have +1. Okay, alkali metal always have +1. Then alkaline earth metal. Alkali metal means sodium, potassium, rubium, cesium, francium, okay, lithium there. Then alkaline earth metal. alkaline earth metal is equals to +2. That means magnesium, barium, calcium, strontium. Okay, they always will have +2, and aluminium. Aluminium always have +3 oxidation state. Clear? Now next, algebraic sum of oxidation number algebraic sum of oxidation number of all the atoms in a species is equal to the charge on the species. Okay, the algebraic sum of the oxidation number. Okay, and the algebraic sum of the oxidation number of all the atoms in a species is equal to the charge on the species. Okay, let's see. Suppose H2O. So what is the charge on water here? What is the charge in water here? It's a neutral molecule, so charge will be 0. It is a neutral molecule and charge will be 0. So hydrogen is always +1. Till now we know that hydrogen is +1. 2 hydrogen atom is there. So 2 into 1, and oxygen is -2 here, -2. So 0. Clear?
Yes, miss.
Okay. So that means the charge algebraic sum of the oxidation number is equals to the charge on the species. If it is minus, then it will come in minus. If it is in plus, it come in plus. And in case of neutral molecule, the oxidation number, if we do the algebraic sum, the oxidation number will come 0. Now, one important thing. Okay, hydrogen will mostly have +1 oxidation state, but hydrogen can also have -1 oxidation state. It can have -1 oxidation state in hydride. Like sodium hydride, NaH. So sodium is an alkaline earth metal. It's always have +1 oxidation state. So obviously, if it will have +1 oxidation state, hydrogen will be -1, right?
Yes, ma'am.
Huh? What you have said?
Yes, ma'am.
In magnesium hydride, see? Magnesium hydride. Magnesium will always have +2 oxidation state. So here 2 hydrogen atom is there. So 2 hydrogen atom -2 means 1 hydrogen atom is -1. So that means in case of hydride only, hydrogen will show its minus oxidation state. Otherwise, in most cases, hydrogen will show +1 oxidation state. Clear?
Yes, miss.
Okay. So let's start calculating oxidation state. First, calculation of oxidation state of in H2SO4, we have to calculate the oxidation state of sulfur. Okay, so here H2SO4 is a neutral molecule. Here H2SO4 is neutral molecule. That means the total charge on the atom will be 0 because it is a neutral molecule. Okay, now hydrogen will always here +1. So 2 hydrogen atom is here, 2 into +1. This for sulfur, we have to calculate the value for sulfur. So it will be X, and oxygen is always here will be -2. So how many oxygen atom is there? 4. That means 4 into -2, which is equals to 0. So 2 plus x minus 8 equals to 0. That means
Miss,
x,
2 plus x plus 8.
yes, 0. That means x equals to 6. So what is the oxidation number will be sulfur? The oxidation number of the sulfur will be here plus 6. Clear?
Miss, minus minus plus.
Where is minus minus plus?
Miss, it would be plus 8.
No, no, it will be here, it will be plus. Sorry, here it will be plus. Because total charge is 0, here it will be plus.
Yes, miss.
Clear? So now you calculate the oxidation number of, in case of magnesium sulfate, MgSO4. See, the oxidation number of sulfur again. Magnesium is always plus 2. So plus 2. One magnesium atom is there. Plus X we have to calculate. Plus minus 2 into 4, because 4 oxygen atom is here. So here 2 plus 6 minus 8 equals to 0, because total charge is 0. So X equals to 6. So here is also the sulfur will have the oxidation number of 6. Clear?
Yes, miss.
Now you calculate the oxidation number for this one, Fe2O3. You have to calculate the oxidation number of iron. You calculate and you tell me. So iron we have to calculate. So obviously the oxidation number will take X, because we have to calculate, and oxygen will be, one oxygen will be minus 2. So let's see. So 2x, okay, 2x plus minus 2. How many oxygen atom is there? 3. So 3. So, and obviously total charge will be 0. Total charge will be 0 because it's the neutral molecule. So here 2x minus 6 equals to 0. 2x is equals to 6. X equals to plus 3. So here the oxidation number of iron will be plus 3. Understood? Yes
miss.
or no? Clear?
Yes, miss.
Yes, ma'am.
Now next. Here you have to calculate the oxidation number of this one. S2O7 2 minus. Here you have to calculate the oxidation number for sulfur. Oxidation number of sulfur you have to calculate. So we have to calculate the oxidation number for sulfur. So it will be X. We have to calculate the oxidation number of sulfur, means it will be X, right? So how many oxygen sulfur atom is over here? 2. So it will be 2x. Okay. Plus how many sulfur or some oxygen atom is here? 7. Oxygen atom is here 7. So 7 into minus 2. What is the charge on the atom? Minus 2. Let's do the calculation then. 2x minus 14 is equals to minus 2. 2x equals to minus 2 plus 14. 2x equals to 12. X equals to plus 6. See, understood or not?
Yes, miss.
Okay, now you tell me, you do one, that is oxidation number. You have to calculate the oxidation number of COO3 minus the oxidation number of chlorine. You calculate. So chlorine will be X. So obviously X plus oxygen over here is always in -2 because chlorine is more electronegative than oxygen. So oxygen will be here in -2. Chlorine is more electronegative than oxygen. So how many oxygen atoms is here? 3. So 3 into -2 is equals to -1 because total charge is -1. So X minus 6 is equals to -1. X equals to -1 plus 6. X equals to +5. So here chlorine is in +5 oxidation state. See, clear or not? Clear or not, boys?
Yes, miss.
Okay. So one more thing, just like fractional oxidation state also will have, like in case of Fe3O4, suppose Fe3O4. So Fe we have to calculate. So 3 Fe ion minus 4 into -2, sorry, plus 4 into -2 is equals to 0. So 3x equals to 3x minus 8 equals to 0. So x will be 8/3. Okay, x will be 8/3 means 2.67. So fractional oxidation state will also occur. Here iron have oxidation state like 2.67. So fractional oxidation state also occur. It's not like that fractional oxidation state not occur. Okay, so regarding the fractional oxidation state, we will learn obviously in detail. Okay, so till this much it is clear.
Yes, miss.
Yes, yes, ma'am.
Now your homework will be, write down your homework. You have to calculate the oxidation number of BrF3, Br here, then in methane, carbon, in Na2B4O7, bromine, sorry, boron, in Na2B4O7, boron, in Na4 FeCN6. You have to calculate the oxidation number of iron, then Na2S4O6, this sulfur, and Pb3O4, this Pb. Clear? Write it down. This will be your homework.